Hey, this is Mr. Muller with a quick video to go over slopes of parallel and perpendicular lines. So remember, slopes that are parallel are exactly the same. So like this one says 5x plus 4. So the only thing I know about that second line is it's going to be 5x, and then something else is going to be different at the end. So parallel means they have the same slope. Perpendicular means they have the opposite reciprocal. And what that means is they have the opposite sign. So if your slope is positive, it's going to change to negative, or if it's negative, it's going to change to positive. And reciprocal means it's going to get flipped around. So if it's something like 2/3, it's going to get flipped to negative 3/2. Usually with fractions, they're a little easier. They get kind of tough with these whole numbers. So like if they were asking for the perpendicular of 5, it's really going to be negative 1/5. So with whole numbers, it's a little trickier. This is another time in math when fractions are easier. I know usually fractions aren't easier, but usually they are here. So we're looking for a new equation, and it gives us y equals 5x plus b. We need to figure out what b is. So, and it tells us over here that x is 8 and y is negative 2. So remember, the first number is always x, the second number is always y. So instead of 5 times x, I'm going to say 5 times 8, and that's 40. Instead of y equals, I'm going to say negative 2 equals. So now I'm at negative 2 equals 40 plus b. And so to get rid of that plus 40 there, I'm going to end up subtracting 40 from the left side. So then I have negative 2 minus 40, which is negative 42. So b is negative 42. Here it says a rectangle is graphed on a coordinate grid, which represents the equation of a side that is perpendicular to side S. Okay, so parallel lines are like S and Q. They're parallel, they're never going to touch. P and R, they're parallel, they're never going to touch. So parallel lines are like railroad tracks when we see them. They're just going to go on forever and they're never going to touch. Perpendicular are lines that cross at corners and at 90-degree angles. So like S and P are perpendicular because their lines are going to cross. S and R are perpendicular, their lines are going to cross. Same thing, Q and P are perpendicular, Q and R are perpendicular. So we're looking for a line that's perpendicular to line S, and it's going to end up being line P. So we need to figure out what the slope is here for line P. It could be line R as well, but since I know the answer, I know they're talking about line P. So the slope here, so if I'm looking at this point to this point, for line P, it looks like it's going up 1, up 2, and then over 1 over 2. So 2 over 2 is really the same as 1. So we're looking at 1x. So now we're between this one that says x plus 9 and x plus 3. And if I just pretend that this P line is continuing here, continue, it's going to cross at 3 here. So it's going to keep coming down, and it's going to come between 4 and 2 there. So it's going to be x plus 3. Same thing here, we're looking for an equation that is perpendicular to side D. So D is here. So we're either talking about line A or line C. And this time we're actually going to be talking about line A. And it really helps here with line A is it tells us where that y-intercept is. It's crossing. And it tells us it's at 0, 5. So we're looking for something that has a 5 at the end. So now we're down to this one or this one. And if you look at line A, from left to right it's going down. So I know it's going to be a negative slope, so I'm looking for that number in front of the x to be negative. So since it's multiple choice and there's only one negative number there, I'm not even going to count it. I know it's going to be negative 2x plus 5. Okay, here we're looking for something parallel to this. That means our slopes need to be the same. So here I'm at 8, so kind of tricky. These each go down by 2. So if I go down 2, down 4, down 6, down 8, and then I go over 2, well, that's really negative 8 over 2, so I'm looking for something that's negative 4. Remember, parallel lines have the same slope, so the only one with a negative 4 slope is this second one here, negative 4x plus 3. What can be concluded about the graph here? The polygon is a rectangle. Nope, it's not a rectangle. Like if it came out here, then it would be a rectangle. Adjacent sides of the polygon are perpendicular. Again, same thing. Since this line doesn't cross at a 90-degree angle, it's not a straight line, it can't be perpendicular. Opposite sides of the polygon are parallel. And again, because D and B, this D line isn't straight, it's going to go crooked here. Eventually, it's going to keep coming up, 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 and B is going to keep going straight. Somewhere way up here, they're going to end up crossing. And then the slope of line C is 0, and that is right. It is a horizontal line, and all horizontal lines have a slope of 0. All right, so here it kind of looks like the exact same thing as like question 8, was it? Yep, except now we're looking for perpendicular. So if you remember in question 8, our slope was, let me go back and look, -4. So the opposite of -4 is positive. So we only have two positives left, 4x and 1/4 x. And remember I said opposite reciprocal, so the opposite of -4 is positive 1/4. So the only one with a positive 1/4 is option C. Hope that helps.